Okay, so still in chapter 3, and we're still talking about describing or examining our distributions. So we're still hitting up our socks, discussing socks within our distribution, okay? But now we'll try to get a little bit more specific, okay? So let's start talking about uh, more specifics when it comes to our shape, okay? So when you describe a distribution shape, we should concentrate on the main features. We're looking for a few things: major peaks, not for minor ups and downs, but major peaks. We're going to be looking for clusters of values and then obvious gaps. We're going to look for potential outliers. That could be where those gaps come up, okay? And not just for the smallest and largest observations. And then we should also look for rough symmetry or clear skewness. And those things are really important to us, okay? So always addressing the idea of whether we think they're symmetric, roughly symmetric, and or if we see any skewness within our distribution. So let's kind of talk about what the idea of those two things are. So a distribution is roughly symmetric if the right and left sides of the graph are approximately mirror images of each other. They don't have to be perfect. It just has to appear to be symmetric. It won't be exactly symmetric, and you will still say that they are roughly symmetric. A distribution would be skewed to the right, or right skewed, if the right side of the graph containing the half of the observations with larger values is much longer than the left side. It is skewed to the left, or left skewed, if the left side of the graph is much longer than the right side. So let's kind of take a look at what that may look like. Okay. So that first graph down here, okay, again, not perfectly symmetric, okay, but we can definitely describe this graph as being roughly symmetric, okay. We can definitely see a longer tail here to the left side, whereas this graph here would definitely have a longer tail to the right side. And so we would explain this one because the tail end is to the left. We would say that this is left skewed, where in this one, the tail end is to the right. And so we would explain this as being right skewed or skewed to the right. So you always think of the direction and where the skew is would be, where is the tail? If the tail is to the left, it's left skewed. If the tail is to the right, it's right skewed. Here's more of the same. And now the idea of those peaks. So the peaks are going to be important. So the peaks are they're identifying your modes. What is occurring the most often, okay? So if you have a single peak, you have one mode, okay? You would explain that as being unimodal, as opposed to having two modes, or you know, more than one, I guess I should say. You if you have two major peaks, you'll describe this as being bimodal. Okay, so this would be bimodal right here. Okay. There are, of course, situations that you can have more than a bimodal, but you wouldn't say tri, you would just go for multi. So anything after a bimodal would be multimodal. So the EPA's the EPA's estimates of miles per gallon on highways for mid-sized cars, that graph would have been multimodal. You had peaks at several points on that one, okay? It would be described as uniform if you had the same mode for all. So you're looking at a graph that you wouldn't typically see here this year. But if it's all uniform, that means that everything occurred at the same. Okay, so let's just compare some distributions and then move on with this video. So some of the most interesting statistic questions are going to involve comparing two or more groups. So I think we'll cut this off at this video, and then we're going to start to compare distributions in the next video. So now we have a few, we could get a little bit more descriptive in our comparisons now that we know a little bit more about shape.